Next, let's take a look at how to write our own functions. So our programmer-defined functions, that is, you are the programmer, you want to write your own functions. So as we saw before, functions are the building blocks of entire programs. You can set up a whole bunch of functions and create an entire program. And that's usually how C programs are written. C++, in addition to having just functions, also has classes. So just like Java. In Java you have classes. Put a whole bunch of classes together, that's what builds up your program. So you instead of solving a problem with just one function, we divide up the job into multiple parts, and that's how you make the problem simpler and maybe easier to maintain the program. Also increases readability. If you have one big function to do everything, one big main, it's not a good idea. It becomes pretty hard to read. Plus, if you have, let's say, the same code in two different places and it's just slightly different, chances are you can write a function. That's simple reuse. That's called reuse. That's a simple reuse of code. Instead of having, let's say, two chunks of code that are doing almost the same thing, except just slightly different, you can put that code into a function and just call it twice. That way, among other things, if you have a bug in one of them, chances are you have a bug in the other one too, and so you fix it in one place if you have functions. Okay, so in C++, sort of like in Java, you will have definitions and declarations. So your definition is the entire function. It can go into either the same file as main or as a separate file. In C, the convention is to put each function into a separate file. Different from Java in that in Java, you put each class into a separate file. In C, the convention was to put each function into a separate file, and that's still done in C++ as well. Okay, so we are going to stick to just putting functions in the same file as main, because it's not that complicated. So there are three pieces to using functions. One is the function declaration or prototype. This is just enough information to have the inputs or the parameters and the return value. This is information for the compiler so that it knows how to handle calls to that function. So in Java, the only thing equivalent that we have is abstract methods. That is methods without a method body. We're just giving the method name, its return value, and the input parameters. And then if you have abstract methods in Java, we actually define those methods in a class that inherits from the abstract class. C++ is actually a little bit different in that you sometimes need a function declaration, and then the definition might go somewhere else. The actual code, actual method body in the case of Java, the actual function body is what's called the definition in C++. Let's take a simple example. So let's say we want to compute the average of two ints. How do we do that? We can set up our own average function. So we will say int, or let's say we're going to return a double average, and then int x1, int x2. So remember, like in Java, you can't say int x1, x2. It'd be nice if you could do that. No, you have to have the type for each input parameter. Okay, so this looks like an abstract method in Java. That is a method without a method body. Well, this is called a function declaration, and this is different from a definition in that the definition you can put elsewhere in a different file or in the same file but later. And you can you can give the function definition. So this is the declaration. I'll put a comment here. declaration of average function, copy and paste. And this is not the declaration, this is definition of average function. We do the same thing, int x1, int x2, and here we say we return x1 plus x2 divided by 2. I gotta fix this up. With parentheses, or else I'll get the wrong answer. You guys know that. Okay, so I use the 2.0 to convert it to double. It's probably not good. You know, you wanna, maybe it's better to do this. Double, and then even better to use static cast. Alright, so there we go. Oops, we haven't used it. And let's say double z equals average x, y. Okay, so let's take a look at this. We have to add some code to print out the average. Okay. We don't need any library functions. We defined our own function. We are using random. Sure, that's a library function that came from CMath. Okay, save it. Compile it. I hope we don't have any errors. Okay, we're good to go. And we'll run it. Alright, average of 15 and 16 is 15.5. Good. Looks like everything works. So let's take a look at this. Here is the declaration. In the declaration, turns out you don't really need names. It's fine if they're there. If they're not there, what Java really, C++, what the C++ compiler really needs is the type of inputs and the return value and the name. And then it says, okay, wherever you see an average, assume that it's going to have 2 ints as input and it's going to return a double. So you better check that. It will check, is x compatible with an int? Yes, it is. It's an int. Is y compatible with an int? Yes, it is. It's an int. And the return value is a double. So is this return thing compatible? Yes, it's a double. So that's what it'll do. Let's check that. Let's compile it. And let's run it, and everything works just as before, even after you delete the names. You can delete it. I would say leave it in, but it doesn't make a difference. You can call it something else too. A, B, save, compile. It doesn't matter. Run it just to make triple sure. Yes. Still works. Okay, so that's a quick look at how to write your own function. You can do a declaration here, put the body here. Well, let me just show you one more thing. That is that you can cut this, paste it up here, and this will work fine. Okay, so this will work fine. So having the having the declaration and the definition in one place, that is perfectly fine. And we could have done that. It's just that sometimes we want to have the main be visible right away to whoever's reading the program. So let's compile this and run it. Okay, works fine. So you can have the declaration and the definition in one place. You can have the declaration at the top, the definition below the main. or you can have the declaration here and the definition in a different file, and that would work as well. You do need the declaration if the definition is not ahead of main. Let's say if you put the definition below main, then let's just try it out. I believe you'll get an error message because of the way compilers work. Sometimes you need that declaration up here. So what we've done is, in essence, is taken out that declaration. Let's compile this. I'm guessing, yeah, we got a compile error. It says, what is this average thing that you talk about? And so how do we fix it? We sort of go back to what we had. I can undo it, but I'm going to copy and paste. And remember, you can have this. You can remove the names. That will also work. Compile this, and we no longer have the compiler error. So which tells us we have to have this declaration up here so that when the compiler sees it being called, it knows what this thing is. Can't it look over here? Sure it can, but this is a technical thing that has to do with the way compilers work. Okay, so we saw the three pieces: the declaration, the actual implementation of the code, or the definition, and then a call to the function. Okay, so call is where we call the function. So let's look at some of these things in a little bit more detail. A function declaration is also called a function prototype. So you'll see that word in error messages. If you have an error, it'll say missing prototype or something like that if you don't declare it where it expects it. And this is an informational declaration for the compiler. It tells the compiler how to interpret calls, so that where it sees a call to a function, it knows what the parameter list, what the types should be, it knows what to return, and so on. And it should be placed before any calls. Remember, we saw that we had to put that above main in the global space. So we'll talk about global space too soon. The definition in Java, we call it the method declaration and the method body. That's the open curly brace, close curly brace. That's the compound statement that the function is that the function implements. Okay. Function definition, as we saw, is usually placed after the main function, and it's not inside. You can try to do it inside. Actually, to tell you the truth, the newest version of C++ makes functions a first-class object, and it has what's called lambda, something that C# has had for a long time. So C++ is a little behind C#. So there's tiny differences. So not everything that you will see here is like the gospel truth. There are some minor differences that will come about because of C++ version 2011. We're not going to talk about those new changes. Okay, so just keep in mind there are some tiny differences. If you try to put a function inside a function, let's just say for now that it won't work. Functions are equals. That is, you have a flat hierarchy. There is no hierarchy. All functions are sort of at one level. No function is ever part of another. This is all sort of not true in Java. In Java, you can have functions or methods inside methods and classes inside methods and so on. Not true in C++. Okay, so in the rest of this we know the parameters are just formal placeholders for data that's sent in. Return statement sends data back to the method that called it, or the function that called your function.